Most of the errors that come from the machine actually happen because of the way we handle the blood sample before we get to the machine. So there's just a few simple steps we can take to prevent our results being inaccurate. So number one, first thing we're going to do, we're going to take a venous blood gas syringe, which we've got here, and we're going to drop a blood sample into it. So what we can see within this syringe is a ball bearing, which is magnetic, which helps us agitate the sample gently. The white square in there is heparin, and we can also see a black line on the syringe which indicates when we've got sufficient blood to run the sample. So if you can get 1 ml of blood, that's great. Then you've got a nice ratio between heparin and blood. But if you only have a little bit because of the patient's condition, you can use less. The machine doesn't require a great deal to actually run a test. So the first thing we're going to do is put the cap on. And then we're going to hold the syringe vertically, and we're going to push the air out. So the blood goes all the way up, halfway up the cap, and then it locks. So there's a self-locking mechanism there. If we had air bubbles still in the syringe, gas could diffuse from the bubbles into the blood itself and just change the result. So we've got rid of that. The sample is now heparinized, so we're now going to gently side to side agitate the sample, and we're going to go up to the blood gas machine and try to run the sample as quickly as possible. If we leave the blood in the syringe static, it might clot and then the machine will get broken temporarily. One thing we're not going to do is shake the sample, which Diego will demonstrate now. If we did that, we risk hemolyzing the red cells, and then we'll see all sorts of blood values go off, such as high potassiums. So it's a gentle handling of the sample. So we're at the blood gas machine now. We're about to run the sample. The reason we know it's able to be used is that all the tests are lit up in green along the top, which means they'll all give results. If there's a red one there, then that result won't come back. And the machine looks ready to use. So the first thing we'll do is mix the sample. And that just prevents the red cells from falling to the bottom of the sample and the plasma to the top, and makes sure it's going to give an even result when we're ready. Okay, so here we've got the arterial syringe. Now the only reason I'm showing this, obviously people who use arterial syringes are trained to do a stab. So that might be the PERT team, it might be the doctors. These are the blood gas syringes that you'll find on the crash trolley. And so if someone tries to use this for a venous sample, they could run into problems. So I just want to show you how to problem solve that if it happened. So if we open this packet, right, and now we'll just look at the plunger and the base of this syringe. So it's actually hollow. So this allows air to escape when the arterial pressure is filling the syringe. So if you were using this arterial syringe to try to take a venous sample, the hole in the plunger would stop the syringe from being able to create any negative pressure. And if you put it onto something like a cannula or a butterfly or a PICC line, you wouldn't actually be able to draw back. You'd draw back, but the blood wouldn't flow. So what you'll do is you'll take the cap and invert it and put it on the base of the plunger, blocking the hole. With the cap now covering the base of the syringe, you can now draw back and generate a negative pressure, fill a venous sample using this type of syringe, and then you can take the cap off the bottom and put it on the top and run it to the machine.